Okay, we've got our signs written around the circle, except for I don't. I do on a different paper, but. Okay, before we fill out the rest of the information, we are going to start graphing. So the equation we will be graphing is y equals sine x. And when I look at y equals sine x, x is going to be the theta, the angle. That's going to be my x value. And then the y value would be the sine at that angle. If you can't see and you'd like a closer seat, I've got all kinds of floor space. My bad. Sorry, I couldn't move it fast enough for you. So sine of the angle, and then y, that would be x. No, that would be y. Y is the sine at that angle. X is just the angle. So as we look around here, the very first x that we would have would be 0. And then what is the sine at 0? We just said earlier. 0. Okay. So the next x, we're going to go counterclockwise around the circle. The next x is going to be pi over 6. So this is not the same as the unit circle. Our x is going to be the angle. And then the y is going to be what? Sine of pi over 6 is half. You already wrote it down. So what I'm going to do now is I'm going to show you the y value. This is where I'm using my color. There's my y value. There's that half. So I go like, yeah, mine bleeds through too. And then pi over 4 is the theta, that's the angle, and at pi over 4, our sine is radical 2 over 2. And did anybody find that as a decimal? Approximately 0.7. 0.7? Yeah, we'll just go with 0.7 because how accurately can we graph? Then the next y value is radical 3 over 2. And what is that as a decimal? About 0.9-ish, 0.85, something like around that. And then the next y value at pi over 2 is 1. And then we keep going around the circle, and our next y value is going to be at 2 pi over 3. So we're looking at the y value, which is also radical 3 over 2, or 0.9-ish. And then the next one, 3 pi over 2, is radical 2 over 2, and that's about 0.7. Then we've got 5 pi over 6, that's a half. And then at pi, it's 0 again. So you can see that the y values starting at 0 are getting bigger all the way until we get to 1, which is our max. And then from there, they're getting smaller. Past pi, when we get to 7 pi over 6, what happens to our y values? Become negative. So we're going to be at negative a half. And then it goes down to negative 0.7, which is like negative radical 2 over 2. Then we go to negative 0.9-ish. And then we go down to negative 1. So they're getting more and more negative. Oops, we're getting more and more negative as we go until we get to negative 1. When we get to 5 pi over 3, it now is getting less negative. So negative 0.9, negative 0.7, and then negative a half. And then we get to 0 again, which I guess we get to 2 pi now, and we're back at 0. So we made one cycle all the way around the circle, but we don't have to stop after one cycle. So let's say I keep going, and now I'm going to go 2 pi all the way around plus another pi over 6. And now I'm back at a half again. And if I go all the way around 2 pi and then I go another pi over 4, I'm back at where I was before. So as I'm going around again, it's going to go get more and more positive until I get to 1. Then it gets less, less, less till I get to 0. And it goes more and more negative till I get to -1. It goes less, less negative till I get to 0. And then it repeats again and again and again, infinitely many times. What if I did negative angles? What if I started at 0 and I went negative pi over 6? What if I went the other way? Would there be a difference in the pattern if I went the other way? It would start with the negatives, right? But it's going to be all those same numbers, isn't it? So all the way around once, one cycle is called a period. Isn't that health class? Not to make anybody uncomfortable. But once around is a period. Okay? And the period happens over and over again in the same cycle. Over and over again. Forever. Huh? Until menopause, yes. I guess. Anyway. We're now going to take that and put that in the table, and I have not given you enough spots in the table for every single value on here. We'll just start putting them there, and then we'll figure out the pattern from there. So the x value is what? What goes in the x spot? Avery. What goes in the x spot? I don't know. What goes in the x spot? The angle. So what angle do we start at? 0. And then we go to pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3. I'm going to stop saying them out loud now. So I was able to fit through pi over 4, and we will graph the complete cycle, but there's no sense in putting all of it in the table. But just to, so we understand where the graph's coming from, we'll put these in the table. Now I have to go put my sign at x in. So the sign of each of these angles we're going to put in, but we've already put it on the graph, so it should go pretty fast to write it over here. You don't necessarily need the decimals. I just put them on there so you know how we're graphing. Now, you should have graphed this last year. And we will, when we actually graph these for real and do all of our assignments, we're not going to graph every single one of these points. We're going to do it one time. This one time. Then from there, I'll tell you which points you just need to graph, and you'll be able to connect and make your same picture every time. We're just going to graph all the points just this one time, okay? You can do it this one time, right? You can. You can do it. Okay, so I'm going to graph 0, 0. And I didn't put any numbers on the y-axis, but since we're graphing decimals, let's put 1 up there at 2 marks, and let's put -1 so that we can a little bit more accurately graph decimals. So 0, 0, and then I have to graph pi over 6, but I look here and I just have labeled pi over 2. So, what's the middle between 0 and pi over 2? That's pi over 4. So it's still not pi over 6. How many pi over 6's fit between 0 and pi over 2? Let's think about angles. Between 0, what's pi over 2 is I'm sorry, degree? 90. So between 0 and 90, pi over 6 is how much? 30. 30. So many 30s fit between 0 and 90? 3. So you just have to divide this section into 3s, which would be about here and about here. It's not exactly, perfect or anything. So that's where my pi over 6 is going to be, and then my 2 pi over 6, which is pi over 3, will be that second one. And like I said, this is the only time you'll have to do this part. But it's good conversation to have because there will be some that you might have to divide up later in other instances. So I'm going to graph pi over 6 and then a half. Then I'm going to graph pi over 4, approximately 0.7. Pi over 3 is that next line that I created, and that's about 0.9-ish. And then pi over 2 is 1. And then I'm going to continue the pattern, filling out my table. It's this one right here, where it's like closer to the pi over 4 than it is to pi over 2. You see where I'm pointing? Yeah. I guess I could have made those in different colors. But. So I'm just going to continue my pattern. And I'm using my sine values from the unit circles since my table wasn't as big as I need it. And I'm going to do my best job to connect these. And then I'll move my hand so you can see. Now, if you're already done with that part, we're not going to leave that big empty area on the left side just like empty like that. We're going to continue our pattern and find the other side. So it would be like you're going negatively around the unit circle. So a negative pi over 6, that negative pi over 4. And you can just use your unit circle, go the other way. I will graph it too. But it would be helpful for you to think about what's going to be next. Like I said, this is the only time that we're going to graph this many points on one of these graphs. The only time. I colored in one cycle. Just so you can see that there's more than one cycle represented up here. I just colored one of them in. Where you might struggle a little bit is when I get rid of some of the points, you're going to want to make zigzags. And you can see right now with these points, these are not zigzags. How would you describe waves? Rolling hills. See, they're like curvy. They're not zigzaggy. Okay. When you are ready to go on, we're going to do the same thing with cosine. starting from the circle. We're doing the exact same stuff with cosine. So you have your values in. I didn't put mine in yet. This time when we write the equation, are we ready for cosine? We write the equation. It's going to be y equals cosine x. But this is a little tiny bit confusing just for a moment. What is the x? It's going to be theta, or the angle. And what is y? It's going to be the cosine at that angle, which we know is the x value at the unit circle. So it's a little confusing because x is really y or y is really x or something, but like it's just the cosine at that angle. So the x values in the table are still going to be 0, pi over 6, pi over 4, pi over 3, pi over 2. They're just going to be the same thetas. I'm going to go back to the table because I want to do the picture first, like we did with the first one. So the cosine, since we know the cosine in the unit circle is that x value, the cosine at each theta is going to be the x. So I'm going to draw for the first one. What is my cosine for the first one? For 0 degrees is 1. And cosine's x, so it's the horizontal value. So for pi over 6, it's about 0.9, that radical 3 over 3. At pi over 4, it's radical 2 over 2, which is that 0.7. And at pi over 3, that's the half. And at pi over 2, it's 0. So cosine is beginning at 1, and then it's getting smaller until we get to 0. Then what happens at 0? What happens next after cosine goes at 2 pi over 3, I should say? What happens to cosine? Why did I change colors? It's negative now. It's now negative half. And then we've got negative 0.7. And then negative 0.9. And then negative 1. So it's getting more and more and more negative till we get to pi. Then past pi at 7 pi over 6, you see it gets shorter again. So negative 0.9, negative 0.7, negative a half, and then 0. And then past 3 pi over 2 at 5 pi over 3, what happens? Oh man, I did the wrong color. What happens to cosine now? Must be purple. It becomes positive again, and now it's getting bigger. And bigger. And bigger. Till we get back to 0 degrees where it's the biggest it will be, 1. And then it gets smaller again, till we get to 0. Then it goes more negative till it gets to negative 1. Then it gets bigger again till it gets to 0. And then it gets more positive till 1, and so on. And again, well, what's the period of one cycle? What's the length around? How many radians for one cycle? 2 pi. So all the way around the circle is just 2 pi. So you're going to have the same period as sine. And if you're looking at, can I borrow somebody's that did colors? If you're looking at cosine and sine next to each other, let me zoom out for a second. If you're looking at cosine and sine next to each other, they kind of look a lot alike. How could I make them look the same?
Add the line. Oh.
How much should I rotate it? 90 degrees? And then they're like exactly the same. Look at the numbers. They're the same when you rotate it. All right, let's go back to filling out our table and then plotting the points. Fill out your table, plot the points. I'll do it too, so you can kind of check to make sure you're doing the same thing I'm doing. Something stuck in it? So we go to graph cosine. This one where sine started at 0, 0, this one starts at 0, 1. Oops. So I have one period of cosine graphed, and I will continue my pattern just one moment once I color this one in. So you can see if your graph looks the same. You can see the cosine graph kind of looks like just one big valley, where the sine graph had a hill into a valley. This one's just one big wide valley. And then my arrows at the end don't go straight up. My arrows at the end, they don't go straight up. They curve around because that's where I'm going to go next, if I were going to go further. Make sure they do not look zigzaggy, but they look like nice rolling waves. That's the only time, what you're doing right now is the only time we're going to have to grab all those dots. Because if it always looks the same, if we could just find some key dots and use those to connect, that'd make our life a little bit more efficient. If you are waiting to go on, because there's few people still graphing, if you're waiting to go on and you have your graphing calculator, you can try graphing sin x or cosine x in the graphing calculator, but your window is going to be something that you're going to want to fiddle around with. Under Zoom, there is a trig window. Also, you should be in radian mode to make it look like mine. If you're in degree mode, it won't look the same. There's under Zoom, if you hit Zoom, there's an actual trig window, like Zoom trig something like that. If you're writing either one, you can graph it on your calculator. Check it out. This would be a non-calculator quiz or test, but while we're learning, of course, check your answers. So the next page is about transformations, because we are about to do transformations, but I should have done this page first. I kind of have the pages flip up. So go ahead and skip to the next page. And on that next page is where we are going to put the points, like the minimum points that you would want to graph to find your sine curve and your cosine curve. This is where we're going to come up with our parent function points. And there's only 5. Out of, however, I don't count how many we just did. There were a lot. For one cycle, there's only going to be 5. And if you want to think about the ones that were the easiest to graph, I'll flip back here. The ones that were the easiest to graph out of all these, what do you think were the easiest ones to graph? The 0, because it was at 1. The pi over 2 was at 0. I mean, I already have it listed which ones we're going to do, right? But if you're looking at the y values, the cosine x or the sine x, they're the ones that have either a 1 or a 0 or a negative 1. Those are the easiest ones to graph, because on this graph, where are the ones and the negative ones? According to this graph, where are the ones and the negative ones? It's the maximum and the minimum point. And then where's the zeros? Right in the middle of the graph. So those are like the most important points. So for cosine, sine, what's the sine at 0 degrees? 0. Remember, the sine is the y value, so at that point at 0 degrees, it's 0. And then from there, it goes up to 1, then it goes out to 0, and it goes down to negative 1, and then it goes all the way back to 2 pi at 0. So there's your parent function point. So we graph those, and by the way, this graph, I gave you the wrong graph. They're the right graphs, the rest of the packet. It's just for some reason I missed this page. This page, I gave you the wrong graph, so they don't have a pi over 2, but that's okay. That's good practice. Here's pi. Here's 0. Where would pi over 2 be? Right in the middle. Okay. So right in the middle at pi over 2, we should be at 1. So you're just going to have to figure out where the middle of those points are so you can graph your sine function. So I'm graphing it, and then I'm going to color in my original cycle, and then I'm going to also graph the rest of it. And I want you to make sure that you didn't make any silly mistakes, because for some reason when we pass that y-axis and you go to the negatives, people do wrong things. It's in between pi and 2 pi, like exactly in the middle. Right, if you think about the unit circle, it's the one that's right in the middle. So I graphed my one cycle a little bit darker, and then I graphed everything else. Just make sure yours looks the exact same as mine. So we cross that y-axis, and people will start doing whatever they want. Well, I'm just showing you, that's just the ones that came from the table. Oh. But then we continue the pattern. I'm just trying to show you that. You don't have to color it in homework or anything. I'm just trying to explain to you right now that it came from the table. So in your assignment, when you're doing this stuff, you're going to have to say how long one period is. So when we look here, it begins at 0 and ends at 2 pi, one cycle. So that's 2 pi long. Okay, cosine. Cosine, we're going to also use these quadrantal angles. So cosine at 0 is 1, and then it goes to 0, -1, 0, 1. So that's the cosine values at each of the quadrantal angles. So we'll go to 0, 1, and then pi over 2, 0, and sorry, I gave you the bad graph again. So make sure you practice that pattern passing the y-axis, going to the negatives. Make sure it doesn't look like a zigzag, but it looks like nice rolling waves. Relaxing rolling waves. So you have a mistake right here. So your waves are like, no, these are big waves, and there's like those little waves in there. See how it doesn't continue? No, it's actually when you went this way, so it's up. Down. Do you see what I'm saying? That's where people make mistakes. And then on the bottom one, you didn't go to negatives at all. This is how you make it. Okay, we are going to take a brain break. If you are done graphing this one, you can stand up, stretch your legs. Do not stand up and start whatever on your phone. It's not a phone break, but stand up, stretch your legs, talk to a friend for a moment. I'm letting everybody catch up. I'm going to pause the video. Okay, we're back to our notes. And I skipped this page earlier, but I'm also not going to really go over it that much because we have already covered how to do transformations. Well, if it's on the outside of the function,
What does phi mean?
that's a constant.
Oh.
That's a number. So if it's on the outside of a function, then it shifts up C units. If it's on the outside in a subtraction, it shifts down. So this is just like something you can go to and look at if you've forgotten things, but I'm going to talk you through it like it's something that we haven't done for a few weeks. Because it is something we haven't done for a few weeks. So go to example 1. And we are going to graph y equals 3 cosine x. So the first thing we want to think about is transformations. Should just, did I skip something? Oh, I did skip something. You know what though? Let's just go to here. Let's just go. Because I didn't get done in the other class, and I ended up skipping some anyway, so we can just skip the first two. We'll just go here. So you guys look at graph y equals 3 cosine x.
No.
And you say, what does the 3 do to the parent function? Vertical stretch factor of 3. Then I'm going to use my table, and we see this is a cosine. So cosine at 0 starts at what? Cosine at 0 is 1, and then it alternates between 0, -1, 0, 1. Both x and y alternate 0, -1, 0, 1. They all alternate the same thing, and they just start at a different place. Then we need to do a vertical stretch factor of 3. So vertical stretch affects which variable? Outside is the y variable. And since it's y, we don't change it. We just straight out multiply all the y values by 3. sinusoidal. We'll get that. And then you only graph the most outer x and outer y, so I don't need this one. I just need 0, 3, pi over 2, 0, and I changed the graph for this page so it's easier to use. And then pi, negative 3, 3 pi over 2, 0, 2 pi, 3.
I like this graph.
Me too. I meant to change the other one. I don't know what happened. So that is one period. That's one cycle. But we're not going to stop there. You're going to continue the pattern. Well, there's where the thinking comes in. What's going to look like past that one period? And you will fill out the entire graph until it doesn't fit. You do not have to color in the one period. I am doing that for notes purposes, so you're understanding what I'm talking about when I'm talking about one cycle, one period. Because when we fill out the blanks, the question is, what's the period? So what's the horizontal length of one cycle? 2 pi.
Is it always 2 pi?
Is it always going to be 2 pi? What would change it? A horizontal stretch or a horizontal shrink, which we haven't done yet. It'll be when we get the examples 5 and 6.
How do you know that from looking at that it's...
Well, when we fill out the table, something would have to be multiplied by the x's.
I mean, like, how do you know looking at that picture?
By looking at the picture, it would be what is the horizontal length from start to finish of what I graphed originally before I started following the pattern. So the part that I colored in was my original graph before I, added in more dots. But it's the horizontal length. So it would be the x's from 0 to 2 pi. That's the period. The amplitude is, if you found the middle, the midline, which right here, the amplitude is how high above the midline and how far below the midline this graph goes.
3.
It's 3. The amplitude is just the vertical stretch or shrink. It's the same thing. But you got to be careful. The amplitude is just the vertical stretch or shrink. But that also means it's not negative. It's just a positive answer every single time. Because a vertical stretch or shrink is not negative. What does a negative do to the graph? Reflection. So that's not included in the amplitude. The next is called the sinusoidal axis. It is known as the midline.
Why don't they just call it that?
Well, somebody before didn't call it that, and we've obviously changed the words, but I want to make sure you've seen the word sinusoidal axis, so if you go to college and they keep saying that, you're not like, what? But it's the midline. And it is a line, so I need to know the equation that makes that blue line. Y equals 0. The domain and range we are going to write in interval notation, which we've done before. Interval notation, all the way to the left, all the way to the right is negative infinity to positive infinity. Range is from down to up. How low does it go? How low does it go? Negative 3, and we put that as a bracket because it can equal negative 3. And it goes all the way up to positive 3 as a bracket because it can equal positive 3. Okay, so we have lunch.